welcome, guys. Mr. Bergman, good to see you. Just to start us off today, why don't you tell us who you took to prom? I'm guessing it's maybe not your wife?
No, see, because I didn't meet my wife till I was 25. So high school prom, Jenny James. She was a sweet young lady, and I liked her. But yeah, we were good friends. It wasn't really like a date in that sense, but we had a lot of fun. I had a great time at my senior prom. How about you?
So this is going to be a sad story, but I was a missionary kid. You guys may not know that. And I was in Argentina, and I had 0 prom. So
Oh, promless.
my prom was non-existent. So I'm glad that we picked this topic just so I could share my personal shame and sorrow. But today we have some exciting stuff we're going to talk about.
So today we want to learn basically about units. Remember just a couple of videos ago we talked about units and exponents. We've been talking about exponents and stuff before, but now we want to talk about the units because the units actually have something that's before them and it has this word dimension or quantity. So I'm going to jot this table down and then we'll go from there. So folks, as we talk about this, we took the word quantity, another word sometimes is the dimension. So we're measuring something, we can measure the dimensions that they have. So length, right? Length is how you measure something in length. And we work in something called the SI system. That's the System International, the International System of Units. You might have heard it like metric system, but it's kind of like metric system with a little tweaks. So, for example, you probably know this, the SI base unit for length is a meter, which we symbolize m, but a non-SI system, so something that's not like would be a foot, right? So that would be in the sort of the US or the imperial system, right? Volume, what's the SI base system, Mr. D, for volume?
Well, we use liters for liquid, and we use meters cubed sometimes, but let's pass on that for right now.
So liters, and then the symbol is just an L, it's a little L, and a non-one might be a gallon. There'd be quite a few other ones, right? You could ounces and cups and things like that. Mass, now this is the tricky one. A lot of people don't understand, but the base SI system is actually a kilogram for mass, not a gram. And of course, well, I just wrote this in, I could have written the word kilogram. And of course, in the imperial system, we might say the pound or something like that. But these are like base dimensions. Length, volume, mass. Density is a weird one because it combines 2 dimensions, and so this would be it's going to be it would be kilograms per liter, right? I guess that's the unit, kilograms per liter, and but you could also say pounds. Here'd be a weird one, per cubic foot. We're going to learn about how to use those kinds of things because volume can also, you mentioned that, could also be density. What about temperature? What's the SI system for temperature?
This is going to be one that's a little bit weird for us here. The temperature is Celsius in the SI system, but they also use something called Kelvin, which I don't know if we're ready to get to right now. Or
it's just Kelvin. Yeah, actually, I would say it's Kelvin. We'd say Kelvin, and it's capital K. And in the non-SI system, we would say degrees Fahrenheit, right? There's Celsius and Kelvin. There's a connection between the two, which we're going to learn about in just a minute. Time, what's the base unit on this?
Seconds.
Yeah. And of course, another unit might be hours or something like that. Now, as a note, let me pick at some tops here. Length and volume. Technically, volume is actually distance cubed. It's distance cubed, but mass, these are, what I'm trying to say is these are ones that are just base. They are sort of their own definition. Now pressure, in the thermometer situation, we saw pressure. What was that measured in? That was in what? Do you remember what those were?
Pounds per square inch, which is...
Pounds per inch square, but that's not how we'd measure it in the SI system. What would we use in the SI system?
Good question.
Oftentimes they use something called a kilopascal, kPa, that's the SI base system, but you're going to see us use something called a millimeter of mercury, or sometimes called a torr. We'll get to this later on in the year. Energy, it's a joule, J, and this would be a calorie. And then, actually, let's not do current, but let's just talk about one more that's called quantity. And the unit on this is called a mole. And the symbol for a mole is an MOL, and there is no non-SI thing. And this is going to be something that's going to be very important in our class as we move forward. You're going to learn all about moles, because moles are awesome. Oh, yeah. And it's a base unit that measures something very important, particularly in the world of chemistry. Now, why do we learn all these things? The key to understanding this is we're going to be learning about something in the next few videos called dimensional analysis. So it's important to understand which dimensions, sometimes called unit analysis or unit cancellation. We have to understand our units before we can do the math with the units. And that leads us to the last part of this video, and we're going to just focus on this issue right here that you brought up, Mr. Dimitrowicz, is that we talked about Kelvin, but you also talked about Celsius. Now let's talk about the Celsius scale. So if you have the Celsius scale is an interesting scale. It's a 0 to 100 scale, or well, that's how it was defined. And what happens at 0 degrees Celsius? This is 0 degrees Celsius.
Water freezes.
So water freezes at 0 Celsius. Now we know that's 32 degrees Fahrenheit, but it's 100 degrees. And what happens at 100 degrees?
Boils.
Yeah, so this is the boiling point. So this, what they did is they took water, pure water, and they froze it. They found it froze, and then they said, well, we're going to make that arbitrarily 0. And then when we boil it, it arbitrarily boils at 100. And of course, there are temperatures below and above this. You can get above 100 degrees. You can get below 0 degrees. I was once in 40 degree below 0 Celsius in Chicago. It was so cold. So you can go above and below this. And so let's talk about the conversion. If I want to convert from Celsius to Kelvin, what's the formula? Do you know what that is?
First of all, the reason that they did that, though, we probably want to address, is that Celsius has negative values. And so scientists, what they want to deal with is a unit of measurement that had no negative values. Right. Also, there's a correlation between temperature and how fast things move, molecules move. So the hotter you get, the
faster they move. Yeah.
They move, right? So they wanted to have a temperature scale that took you all the way down to where matter stopped moving, and they had a special name for that called
absolute zero. Right.
Absolute zero. And we're gonna address that system right now. So if you want to convert back and forth between Kelvin and Celsius, it's really, really straightforward. Yeah,
you just take, go ahead. It's a degree Celsius plus 273 is equal to the Kelvin temperature.
Yep.
Right? And if let's try it simple. Let's say that I got a temperature of 25 degrees Celsius. What's the Kelvin temperature? Well, 25, put in our little equation here, 25 plus 273, so you just say plus 273. What do you get? 298. Now notice I wrote 298K. I didn't write degree K. It's just K, capital K. I don't know why. The degree thing falls away.
You're very fussy about that if you put a degree in there. Can you show them really quickly, because we're doing an addition problem. Can you show them how you got the significant figures? Because we went from 2 significant figures seemingly in Celsius.
Oh, yeah. Well, it's 273 plus 25, and of course, the line of 0 right there, right? So you're adding. Yeah. Good question. Now, let's say I've got a temperature of minus 273 degrees Celsius. What would I do that? So negative. That's not a minus, but it's a negative. So it's super crazy cold. What would I do to that? I would add 273, and I would get 0 Kelvin. Now, that's 0 Kelvin, not okay. That's absolute 0, and as Mr. D, you just said a minute ago, that's where molecular motion stops, because temperature and how fast a molecule moves is a function of the temperature. And as a side note, that temperature has never been reached. They've gotten within a couple of tenths or hundredths, I don't know exactly, of absolute 0 in a lab in Boulder, Colorado a few years back. And that's as cold as they've ever gotten. So you can't actually, that's never been established. If you go out into space, I believe it's like 4 Kelvin or something like that from background radiation. So you say it's super cold out there, which it is, but it's not absolute 0. So you're going to learn how to do this, and you're going to be doing these conversions in class and using these right here, especially as we start doing math in the next couple of segments.
One last little add-on in here. If you're wanting more significant figures with your Kelvin, it's actually 273.15. So my pre-AP kids, if you're going to be doing a little more complex calculation, just be aware that that may be the number that we use. But 273 is perfectly good to use all the time.
Yeah. It's kind of rounded. Again, this is an estimate. It actually probably there's another number after the 5. I don't know what it is off the top of my head, but I'm sure it exists. Speaking of the metric system, Mr. Dmitrich, there's it's a bunch of prefix stuff that we want to make sure we cover. So as I look at this, we've got what I'll call the base unit, right? And the base unit would be something like grams or
Meters.
meters. Thank you. And that's our base. And then if we can go smaller or we could go bigger. And we're just going to cover the most important ones. As we go smaller, we can have something called centa. And centa means 1/100th, right? That's 1/100th, and it's abbreviated with a little c. So example, like cm for centimeters or cg for centigrams. What about going smaller? Centa, what gets smaller than centa?
Milli.
So it's milli. Is double L or one L?
That's 2
Double
L's, I
L.
believe.
Yeah, milli. And that's 1/1000th, and it's a little m. They can get even crazy small. I mean, chemistry land, we do get things that are super crazy small. What's the next sort of level we talk about?
We go to micro.
Micro, and that's 1/1,000,000th. So 6 zeros. And the symbol for that is a funny looking U. It's actually the Greek letter mu. Okay. And then the smallest that we'll talk about is what?
Nano.
Nano.
There are smaller than nano, but we're gonna typically be in this range.
And that is 1/1,000,000,000th, so that's a nano. And then when we get bigger, we kind of keep going up bigger, and we see the first one, there's actually others, we're not going to talk, that's not important. The first one is kilo, and kilo means 1,000. So there's 1,000 grams in a kilogram, right, for example. And that's a little k. What's bigger than kilo, though? What's the next one up?
Mega.
Mega. And mega is a million. And it's a capital M, not to be confused with a little m. And then we have one more.
Which is giga.
Giga, like gigabytes on your hard drive. And that's, of course, a billion. And that's a capital G. By the way, you may be familiar with your computer systems. There's also tera, becomes the next one. And that's a trillionth, or trillion. So these prefixes are going to be useful as we go throughout the rest of the year. Hey, Mr. Dmitrich, any other thoughts on this content?
The only thing I would add is that you see where it says 1/1000th is a milli. Another way of saying that is that there's 1,000 milli in one of our main unit. So it's kind of a pain to work with fractions, right, Mr. Bergman? Yeah. So we can say 1/1,000,000th of something. There must be therefore a million of that thing in one.
Yes. And here's my recommendation, and we'll talk about this a little bit later too, is that it's important that you put the 1 next to the bigger number. The bigger number is the 1, and then the smaller number gets the number. If it's the smaller guys, then it's the thousandth becomes like 1,000 milliliters in a liter, or 100 centis in 1 meter. These are easy because it's 1,000, 10,000, etc., or a million or whatever. Okay, guys, we'll see you guys in class because you guys are awesome.
Awesome.